I'm super pumped to be here. Has nothing to do with the caffeine I've drunk all morning. Hi everybody, I'm Andrew. You may recognize me from my announcements yesterday and today and tomorrow. I run Los Angeles Perlmongers. You're all invited. Come on over. We're friendlier on a slightly smaller group than all this. This is on, right? We're good? Oh, I should be closer. Excellent. And you wanted a thing? All right, we're good? And we are off. So my talk today, Adventures and Failures. It's a sort of a perusal of error handling and exception handling across languages. A few of them are down here at the bottom. Lots of pretty icons, which is a way more fun to make slides. And my title, I might as well give a shout out to MC 900 Foot. Any MC fans? And I like to quote him out of context because it works better for my talk. Making a change is difficult, but I gotta try to get out of my rut. And don't let fear hold you back. Don't let heavy drinking hold you back. Don't just look at these errors and say, oh my God. Let's power through. So let's start with our ancestor, C. So C is sort of the original foot gun. There's lots of chances to do error handling because there's lots of ways to make mistakes. Specifically, since you are allocating your own memory and having to handle your own memory, that's a whole class of errors that you then have to look and check for. And in the C land, there's no exceptions, there's just errors. So when you get an error, first you have to notice, and then you have to do something about it. Well, you don't have to do something about it, but you really should. Now, these are actually kind of tied together because one, you have errors from your mallocs, but two, because you are in charge of your own memory, then the stack only gives you one return value, and so there's a question. When you call a function, does it return the status of the function or the value of the function? And most C has gone with the returning the value. Actually, returning an error code. Sometimes commingled, where it's a positive and it's good and negative is bad, or here's the thing, or it's null. Yeah, and part of that comes from, you are handling your own memory. And so cleaning up your own memory is a thing you have to do. And so the error handling is very important. Here's a neat little example I found of some error checking, kind of what it looks like. Here we have a stack allocated string and a malloc allocated string, and you have to check, okay, was I able to malloc? Was I able to get memory from the computer? Like, this is the level we're at. And you're like, oh, no, I couldn't. Okay, I better just throw an error. So this is some error checking code I found online. Can you see the errors? Because there are several that are not caught. So we do the malloc, we're checking the malloc. So that's the good example. But we're also string copying into a string and not really checking whether or not that worked and if we were bounded. And that's even outside of the scope of this, but I just love that this is from someone's how to check errors in C talk, and they missed that one. And so because C and the Unix environment we're mostly in, and POSIX are all interconnected. So for your system calls, you've got error numbers. So if the system call failed, then you have a valid thing in error. But it's only valid for a little brief period of time. So it's valid only if your thing failed and only right then. Because it's global and it could get reset by the next thing. So if you actually check it wrong, you could overwrite the value of the error before you check the error. Again, foot gun. There's a great talk on this I found while doing all this research from the Software Engineering Institute, working with CERT on how to get beyond error no handling in C. But what I like is that it connects to a couple of CERT issues where these errors are so common that these are things you have to explicitly go and check, and when you're doing security audits, you need to go make sure that these are all handled because we miss them so often. So for instance, detect and handle POSIX library errors. This is a P18L1 recurring bug. Similarly, detect and handle standard library errors. Also a P18L1 bug. And when it comes to how you handle in C and a little bit C++, C++ is just one little corner of this. You have to decide, can I handle this error? Should I check it? And how much error checking you want to do. And actually, if we looked at that one C example, or might as well look at the one here, it gets, a lot of people think it's messy, right? You make a call, and then you have to check the call, and then you have to call the error number. And so the question is, what have we learned since then to make it better? So in C, error handling really depends on the programmer. And we have found that programmers are humans, most of the time, it turns out, and are thus very fallible. And we forget to do things. And so we'd like our languages to make it either automate this away or make it easier to do the good thing than the bad thing. So one that we didn't even make it to this list, sort of a prefix as we move. So C was a high-level language compared to assembly. And now all of our languages are high compared to C, mainly because we get memory allocation handled for us, which makes it easier to unwind some of these mistakes, allows you to be throwing exceptions or doing different error classes. So some of the different approaches that have come out, we've got Erlang with just let it crash. Just code the happy path. It's kind of mind-blowing to try that. Exceptions were totally common now, but when Java was like, we're going all exceptions, that was new, that was exciting. C++, they're still fighting about it, so that's kind of neat. Go takes a different approach where they require you to check the error, and they nag you in the compiler at the compile phase if you haven't. And then the functional languages have mostly tried to eschew the error handling and go with functional error types, wherein you have one return value that's either the thing or the error, or the thing or the none, partially because they don't have null values, because that was another huge issue with C, is you have all these nulls, you dereference them, boom. So let's try and stop some of the boom. And then static checking, I know we're not big on static checking, but it does get rid of a whole class of bugs. It doesn't get rid of all bugs. But the question is, what are the trade-offs? And JavaScript is doing a lot of continuation callback style. We won't actually get into that one, but it's interesting as an aside of a different way to handle the error checking flow control. Because the question is, how do you keep your code pretty and correct and check the errors? And for me, this all came 2 years back. I was at OSCON, and I did a half-day tutorial on Rust, and then a half-day on Erlang, and their models were so different that my brain kind of melded. Sure, melded. It's kind of both. And so that became this as a lightning talk of just these two being compared. Because in the Erlang model, in specifically Erlang OTP, you let it crash. And it's kind of weird to just say, oh, just let it crash. But what does that mean? What is the environment giving for you? So the environment gives away for, one, it's an actor model. So you're just passing messages around. So if I send a message over here and this dies, it's not going to corrupt my stack and my memory and my process space, necessarily. It may be that its act of crashing affects me, and it may be that it doesn't. And I, as the programmer, can determine, oh, if this one crashes, I want this one to die too. If this one crashes, I want it to just start again and try new messages. And so when you look at Erlang code, it's all just the happy path. It's like, I got this message, pattern match it, do this thing. And if you get a message that doesn't match, you just die. But the VM handles lots of little processes for you. And you end up with this supervisor model, which is really actually pretty fascinating, wherein because it's messages and you end up with a message passing, you can watch from one pool of processes. You can have a supervisor, And then that supervisor can be supervised by someone else, and you have different strategies. So, hey, if one of the kids dies, that's okay, start another one. If a whole bunch of them die, maybe something's wrong, and I should kill the whole class and send it up the line. And it sort of ends up being like exceptions, and it really, if you squint your eyes, you see how we are going towards this exact model in our microservices case of we have all these distributed processes, and we're going to send things, and then we're going to monitor, are they up, and we restart them. And what is nice from their model is that you remove that code into two places. You have the business code, hey, what do I want to happen? And then you have the higher level business code of how do I handle mistakes? And they're separate. And they have 4 strategies, one for all, one for one, rest for one, simple one for one, so that as your children die, you have different ways to restart them all. And again, that's on an actor model, which now is popular in, say, akka and some other places. VertX is not really actor, it's events. But events and message models are getting very popular, and we should play with them. And then Rust has failures versus panics. And so a failure is an error, like an exception that could be handled. And a panic is, no, we don't know how to deal with this, we're just going to explode. And you can't catch a panic. Well, actually, they just decided that maybe you can catch a panic, and so 1.9 added controlled unwinding, wherein you can say, oh, it's panicking, but I know how to fix that. And you're like, why would you need that? Well, you want it if you're embedding in another system and you don't want to fail up. And also, it's functional language, partially. And so it goes with the functional model of a lot of pattern matching so that you have valid cases. And in here we have an example of this last case where you have to have a complete, so your pattern match has to match all available patterns. So you can't have one that just falls off the else chain. In this case, we have one that says, hey, as the programmer, I know that, yeah, I'm getting a float, but it can only be in these values. So if I get something else, yeah, you should explode. But you have to explicitly say, here's my else case, explode. But what they mostly do is what we saw yesterday in the Swift talk of sort of optional types. So you have a thing that either contains the value you want or contains an error or contains a none, depending on if it's a option or a maybe. Most of the functional programs do this. So when you get back something from a function that could fail, like your string parser, that would be expected that sometimes it might get bad data and you need to handle that. It hands you back not a string, but an optional string. So then you actually have to physically take a step in the compile step to say, unwrap this or pattern match this to give me the thing inside. So that, again, you have to explicitly say what you're going to do in the error case. And they mostly don't have exceptions. They kind of do, but they try not to use them. And what are exceptions? Yeah. So Java is the poster boy for exceptions. And they are the only ones that do forced checking of your exceptions. So the exception is actually part of the type signature for a method. So if you want to call this a function that could throw an exception, you have to either handle that exception or declare that you're going to pass it up to your caller. Although this leads to a slight controversy because there is a class of unchecked ones, the runtime exceptions, because you can't really know what's going to happen. That's the problem. With these exception models, you think you know what's going to happen, but then, you know, maybe your RAM is missing. Somebody pulled it out. Like, you're not expecting that. RAM's pulled out. Good example. Good example. So you've got runtime exceptions, and so you can declare your exceptions as run types so that you don't have to put them in your type signature. And this is like really bad, and yet really easy. So it's kind of a dirty little how to get around the unchecked exceptions. But on the other side, you've got Python and their exceptions where you only declare them maybe in your documentation. And so then you have to watch your code for when it fails. And it can be very frustrating as a Python programmer when you have some code that fails occasionally that you didn't see in testing, and you don't actually know what exception is being passed, because then you have to simulate it to figure out what the exception is, or you dig into the code to find it, because it's often not declared. But part of that is this is from the Python glossary, they look at most of the other languages as look before you leap. That's definitely the C style. Check, do I have an int before I call this function? Boom. And they're like, easier to ask for permission. So try it, see if it fails. So this mostly works. It can lead to some strange things where exceptions are flow control. They're just kind of hidden flow control. And sometimes it gets used as non-hidden flow control. So a lot of web frameworks, for instance, you throw an exception to say that I'm handling this. Or that it makes sense. You're like, oh, I want to throw a 503. Sure, throw an exception that gets handled at the top layer. We also say throw a 200 to say I'm done handling this request. And that is not exceptional. That is normal flow control and should probably be done some other way. But the easier to ask permission people have an advantage in that they claim, well, you can't know everything that's going to go wrong. So no matter how defensively you're programming, something weird is going to happen. I agree that you should, consider that, but if there are cases you know will happen, you should handle them, and then leave exceptions for your exceptional cases. A neat thing with exception handling in all languages, basically, but ours, is that you are throwing an exception type or object instead of a string, and we can throw exceptions, objects in Perl 5, but it is more rare. And what's nice about that is then you can do some sort of pattern matching on the exceptions. You can say, oh, if I got this kind of exception, do this. If I got this kind, do that. And it's very clear in the except mapping here. So in this example, if some other exception other than value error is raised, it's going to go up the chain, and somebody else is going to have to handle that. But if somebody, if you ask someone for a number and you're getting user input, you don't know what you're going to get. And if it couldn't become an int, then maybe you should throw an exception. Or maybe you can see if it kind of looks like an int and just accept it. And I feel that's what we more often do, is we're very permissive in what we accept and somewhat conservative in what we emit. And that leads to a whole different class of bugs, because you don't know exactly what is valid and what is not. C++ added exceptions, but they're not really sure if they like them. And at least they have the discussion of, well, if it's a low-level thing that I can handle, I should look at the error numbers, and I should maybe pass that back. And if it's a bigger thing, or it's a structural thing, then I should throw an exception. But then there's a lot of people, our little friend Joel. Joel on software is one of the many quoted names of the I really hate them, they're just go-tos, they're confusing, you look at code, you don't really know what it's going to do. That's a little extreme. In Go, so one of the changes Go went with was, hey, let's have multiple return values and force one of them to be an error. And so all of your functions look like, hey, I'm going to call this function, I've got the value I expect, and I'm going to put in that, and I'm going to expect an error, potentially. And then you check to see, is that error nil? And if that error is not nil, then there was an error, and so you should do something about it. And then many people will rightfully look at this and say, well, that's basically what C was doing, and that was messy, and we didn't like that. And they counter, but it's very clear, and we force you to check it. Because if you don't get that error value, and you don't check it, then you have a, hey, you got an error value and didn't check it exception at compile time. So they force you to write correct code with a little bit of carrot and a whole lot of stick. And it's like, hey, you were writing C, it almost worked, we might as well just figure out how to make it work. So we have automatic memory allocations, so you don't have to do nearly as much cleanup. but you still end up with stuff that looks like what we had in C with some structured go-tos and check. So it's harder to see the happy path, but it's also clear because it's item, check it, item, check it, item, check it. A little messier if you have to do cleanup and you have to keep track of what cleanup to do. But very effective. They're happy with it. For me, this is one of the things that made me look at Go and say, oh, I don't feel comfortable, I don't like it, at a sort of physical reaction. I need to go back and revisit Go and see if that's like a real thing or just my initial whereas, you know, I looked at pattern matching in Rust and I was like, oh, that's so pretty, I love it. And so what can we do a little bit to improve our Perl 5? So one, we got the error checking variant of a lot of our things, especially anything where we're interacting with the system, we have to explicitly check one of our error variables. And we get to do crazy things like on system, it's got the upper bits and the lower bits, and you do some bit manipulate. Come on, I hate that. How many people have written something to call system and like do that for them, and then, but then there was a bug in that, and so they're returning it wrong, and they, yeah, okay. But it's there, but it's not required, and you can forget to do it. So there's a couple ways around that. Oh, well, first, a digression into the error variables. Right, we have 4 of them as you get further away from C towards your own program. You know, nobody really uses, what is it, Control E, because it's a duplicate, come on. But we've got this lovely 5-line example. Managers could set all 4. Because it's a string deval that's opening a file and it's doing a system, and so checking that is exciting. You'll note that they don't bother to actually have the outer eval exception code is not actually accepted. We have some checks inside. So yeah, at, bang, Control E, and question mark for what happened and what happened and what happened. So that's easier to remember. But we don't have built-in exceptions, but we have die and we have eval, and so you can use eval to catch dies and send messages around. Don't do this. This is the hard way. You could bring in try tiny, and this is a much prettier way. And now instead of it being in $@ it's in $_ because that's more consistent and that's what you expect, and so that's pretty hot. But as pointed out to me by my colleague over there, syntax keyword try came out just last year, right? It's new. It's the new hotness because look, no semicolon at the end. That's a real block and not just a thing looking to be like a block. And so you should probably go use syntax keyword try to go try your exceptions. And they are back in at. Unlike try tiny, which put them in underscore, now they're in at. So you can't just switch directly between them because you have to get rid of the semicolons and go back to checking $at. But it's the new hotness, and you might want to get in on that. And another way, and again, we have our own discussion on whether or not this is the way to go, but auto die can take a lot of your manual error checking and say, let's just turn those into exceptions as well. And so now you don't have to do open file or die, you just open file and it'll throw an exception, and then you can do a pretty try catch block around that. So options that you have. I'm not saying you have to do this, you should probably do this. But this is a lot easier than checking that you have done an or die or a system check on all of your calls that could return an error instead of a exception. And then Perl 6, not content to do everything all the time, has decided that yes, you can catch exceptions, and yes, their syntax will be a little bit different. So it's an all caps catch, which will catch any exceptions in that scope. So right, that die happens before this catch, but it's in the same scope, so we're going to catch that. But then once you catch it, you exit the current scope. So it's a little different. And there is a try, This one didn't have a try. You don't necessarily have to try. Yoda approves. But you can try, and that gives you a scope and an implicit catch. I haven't played with any of this, but doing the research for this was super fascinating, especially because we add a continuation. So you can say, yeah, that was an exception, but I don't really think so, so go back to the code and continue. Yeah, that's a thing. I have no idea. Do we have any Perl Sixers in the house who have tried exceptions and resuming them? So this slide is mostly about how to throw an exception. And exceptions are objects now, which is awesome, because then you can do patterns on them. But you can now resume, which is weird to me. So has anybody used resume? Our Perl Sixer in the back? No? I would love to have someone explain to me when you know that it's safe to tell some exception throwing code that it's okay to resume. And so at the questions at the end, I would love to hear about that. Oh, hey, it's questions at the end. So I did, and then I was like, questions, which means answers, and I have 2 hands, and I would love to hear from in the purple there. Mm-hmm. So for the slide, for the people online, that was in Perl 5. Sometimes in character code transitions, you'll see a multiple try because you need to do it multiple times to actually get to a place that works. Is that kind of excellent? The Conway.
One of the reasons that we thought about adding in resumption of exceptions in Perl 6 is that sometimes you get an exception because of an external resource is not available. And it might be that your exception handler can make that available. Maybe you have to mount the volume or whatever. At which point you don't want to have to go through everything again and start again. You just say, well, it's now available. Let's try again.
Awesome. So Damien has commented that one of the reasons we added resume was maybe your exception handler can fix the problem. So you tried to read from a disk that's not mounted, and it can maybe go mounted, and then you can continue from that point rather than having to start your whole function over again. Which, when you put it that way, sounds awesome, and why doesn't everybody else do it? And because of time and more on the slide prep time than in the talk time, I didn't really get to the JavaScript continuations, which were kind of an interesting topic from when I tried this talk last month at LAPM. Go LAPM. In that their continuation style and their chaining style says, no, we don't want to give back a result value. We want to give back the result and then let you keep doing stuff with the result. And to make that work, you either need to be throwing some exceptions or you do what they're doing in their sort of multi-threaded, in their concurrency model, wherein you pass a continuation of when this happens, then go do this, then go do that, using their and then. And that is sort of a way to do the error handling such that it's clear that you're doing this and then that and then that. But a 10-line continuation chain is not any clearer than these other ways. So what I mostly want to tell you is that we can catch our errors, and we should, and we document them. And hopefully you'll get some ideas from what other languages are doing, and yet at the same time not feel like you're missing out because you can do most of what they can. How much time do I have? I'm curious. Like 2 minutes? Okay, cool. So I'll take some more questions if we have any. Let's see. Oh, you in the back. The question was, how do I feel about exception objects versus plain die for Perl 5 exceptions? I'm obviously a big fan. because I think that one, you have more information, and two, it's programmatically easier to work with because your exception object can have that string, for instance, and then it can have other information. So you can change the string, and maybe you need to reword it, and it needs to be clearer, and you can actually change that and not break all of the consumers of your library. Also, doing matches on what is this object, using like is personally a preferred way to strings, because otherwise we're doing string manipulation, which is icky. That said, it's not nearly as nice as a language that has it built in with pattern matching. I mean, unless you're doing some sort of case on the type. But I feel like moving forward to exception objects at all would be a win. And then we can worry about if, oh, there's too many different types of classes and it's hard to match. Because right now we have too many different strings. And I know we love strings, we love regexes. Regexes in your exception handler, to me, anti-pattern. Excellent. Let's see, what do I have left in my bonus slides? Ooh. So a bonus slide on Haskell. So they take the same approach with a monadic either, and mostly because they like to use the word monadic. But a really exciting insight to the change that they made is exceptions are only coming out of code that deal with the outside world, that are impure. They love to be pure. Of course, in a pure world, you don't do anything. So at some point, you have to interact with the user or the system. And once you declare that you're going to interact with the system, now you can start throwing some exceptions. But if you are not interacting with the user, then you're expected to hand back an optional type, which they call what? Either maybe, which contains either the value or the error. But the idea of splitting up between that line of, okay, these are truly exceptional things. They're outside of my world. So I'm dealing with the outside world versus internal things which I should be able to fix. And we can use that when you're writing your libraries, like, okay, did the user give me some bad input? Maybe I can fix it, maybe I can't. Versus the database is down, I should just probably explode. But if there are things that you can handle and you can handle cleanly, you should do that. But sometimes you don't know how to handle it, and that's where exceptions are more useful. You can pass them back to the user or one level of application up to say, hey, we can't really do this thing. What should we do now? And as a library author, you don't necessarily know the right way to handle errors that are at that level. Another neat thing with Haskell, and I'm sure some of the other functional ones have this. So once you have one of these either types, you can apply functions to it that unwrap it, apply to the inside, and rewrap it. And so you can say, do this thing, and this thing, and this thing, and this thing, and once you've chained them all together, if any of those gives an error, they just pass that error through, because each of these applicator functors, each one recognizes, oh, I was handed an error, so I'll just I don't do anything, I just short circuit to error. But if I got a good value, I'll do the next chain. And so this makes the reasoning of the happy path much clearer. So I like it. I've written about this much Haskell. But I was paid, well, okay, I did it while I was getting paid. So that sort of counts. That sort of counts. Because we use a Haskell-based wiki at work, and I wrote a plugin. I copied and pasted most of a plugin. In the back. The question was, do I know a regular meetup in the Los Angeles area where I could discuss this sort of thing? Now, that's interesting. I do know a really good one in New York. But if you're in Los Angeles, I do recommend the Los Angeles Perl Mongers. Follow us on the Twitters. We're not actually on the Twitters, but hashtag LAPM. And we are on lapm.org on a about to be destroyed. We still use WebDAV on the hosted pm.org. Does anybody use that? We got our please discontinue using this message last month. So we might be on Meetup soon. Who knows? Who knows? All right. All right. And with that, I will say thank you. But pitch the booth. There's another question from the front. Are there any awesome booths out there? And the ZipRecruiter plant in the front row says, hey, I've been working at the booth and it's awesome. You should come out and get a shirt. They're very pretty. They're like an 8-bit velociraptor. All right. So historically, my talks have gone way, way, way over time. So I cut a bunch of slides and talked fast. So hopefully now you'll be able to, oh, by the way, that is a shirt. Oh, look at that shirt. Pretty, distraction, and I'm out. So yeah, how many of you do use, I'm curious on some of these things. So Autodie in your sort of personal code, in your work?
Use Fatal instead of.
Oh, tell me more. Use Fatal. Sort of the same thing?
I think so. Use Fatal and Open, yeah.
Oh, use Fatal and Open. That sounds good. If we made all calls to OpenDie, that would be even better, right? Because then we'd be done. Okay. Which is an interesting one with C++, you have assertions, and you're like, oh, I'm going to assert that people gave me a value that's not null and this and that, but then in production, those get turned off. So not a useful way to do error checking. I saw a hand.
So there's a number of exception objects in Perl. Do you have one that you recommend?
I don't currently. I would like to find one that I like, but I don't. The question was, do I have a preferred error object system for Perl 5? And there's another question in the back row which might be related. Yes. Throwable. Yes, throwable is good. I will agree with you on that. Throwable. Alrighty. This is so fun. So, and then how many of you are still catching error? Like, what do you use? Try catch, evals, ignore dies? Anybody? Eval. Have you looked at what you have to do for eval manually? No. Okay, you should probably not just ignore them. I mean, you could do it. It's what Python programmers like to do, right? Oh, you hit Control C, boom, here's a stack trace. And I'm also a Python programmer, so I can say that. Global die handlers. Yeah, that is a thing. So if you use a global die handler, you can catch and do some cleanups, but unless I'm wrong here, that's really hard to continue operating, right? Maybe not. I'm having a discussion with the void over there, so I'm not sure who shouted that out. That was you. All right. So a problem with global handlers is that they'll get called for all of your exceptions, even the ones that you've already caught. Another problem with those is anytime you're doing handlers and then you have handlers stepping on each other and never mind. I'm not going to go into handlers. They're wonderful. They're your friend. Don't use them. Okay. I had another one I wanted to add in my bonus material, but I don't recall what it was. But let's just look at the beauty that is the lambda of Haskell. All right. We'll go back off of that one. Feel free to chat me your other questions. Follow me on the tweets. I have a purple one. Yes.
Anything about failures in Perl 6?
Ooh, do I have anything to say about failures in Perl 6? Failure, singular, and that kind of leads into my answer, which is no, I don't. My Perl 6 knowledge is, at best, rusty, which means pretty much out of sync since while I want to get back into playing with some Perl 6, my last one was at a TOPM meetup, actually, but that was some years ago. We did get the Thousand Oaks release named after us because we tried to write Perl 6, so that was neat. But the last time I wrote it, we were spending most of our time implementing actual interfaces to the world rather than writing our code. So I have no idea. But do you have an opinion on, sorry, after my long rambling story?
I don't know if experience is it. I kind of like it. I have that much experience.
All right.
But
All right. But I'm all in favor of getting our exceptions and our other error handling clean and documented and happy, because then we're happy. And I want you, especially you, I want you happy, okay? Because Graham is sad all the time, and I want him to be happy. All right. Thank you all.